fractions to simplify a fraction and solve a proportion. I know you've done this before because solving a proportion was on your entrance exam. You did learn it in Math 6, so this is going to be another one of those kind of review, just get back into it objectives. Whereas last year, simplifying fractions and proportions were separate objectives. This year, they're the same one. Okay, and so let's start with defining equivalency. What does equivalency mean? Equal what? Okay. Okay. There's a specific word I'm looking for here because, like, if you think about what equivalent fractions are, okay. For example, 3/7 here. What would be an equivalent fraction to 3/7?
Wait. 6/14.
6/14, right? And how she got that was she multiplied both the numerator and the denominator by the same thing. Okay, so I can write that 3/7 is equal to 6/14, even though the numbers are completely different. Someone that doesn't know anything about fractions might look at this and say, how can you say those two things are equal? Because 3 is not equal to 6 and 7 is not equal to 14. The numbers are different. So just saying that equivalency means two things are equal, what's equal about them? Excellent. Okay, equivalency. Two, I don't know, things, I guess, we'll call them things. Two things with equal values. Two things with equal values. They might look completely different, but they have equivalent values. Okay? And how we could justify that 3/7 and 6/14 are equivalent values is because exactly how we got to 6/14, we multiplied both the numerator and the denominator by the same thing. Which, if we were to write this out in kind of a more mathematical, fancy way, we multiplied by 2 over 2. What does 2 over 2 equal? 1. And what happens when you multiply anything by 1? The value doesn't change, right? So even though the numbers change, the value doesn't because we really just multiplied by a fancy version of 1. 2 over 2. Yeah, pretty intense. What is another equivalent fraction to 3/7? And then be prepared to explain to me how you got there. Bennett.
Wait, never mind.
Okay, Aiden?
Hold up, I have one.
There's literally an infinite number of possible answers here. Back in it, Bennett.
9/21.
How'd you get 9/21? Yes. If we multiply 3/7 by 3/3, which also equals 1, right? Something over itself, we get 9/21. 9/21 is an equivalent value to 3/7. Okay? Let's go to 8/10.
Wait,
Yeah, question.
is this right? 12/28.
Sorry?
Is that 12/28?
12/28 would be an equivalent value also. Yes. Yep. Aiden. Next one. 8/10. What's an equivalent fraction and how'd you get there?
20.
And how'd you get there?
I multiplied 8 times 2 and 10 times 2.
Brilliant. 8/10 times 2 over 2, or by 1, equals 16/20. 16/20 and 8/10 are equivalent fractions. Give me another one, James.
800 1,000ths.
800 1,000ths. What did you multiply by?
100.
100 over 100, which really just equals 1, which is why they're still equivalent, right? Because we really just multiplied this by 1, and we get 800 over 1,000. Excellent. Equivalent fraction there, too. Nora.
24 over 30.
Sure. 24 over 30, just amount of space, but if you multiply by 3 over 3, okay, you get 24 over 30. That is an equivalent fraction as well. Sometimes, like in 24/36, it doesn't look like very much fun to multiply because the numbers are going to be pretty big. So, Lucy, what other option do we have here? Oh, yeah.
So should we just circle for the answer the fraction?
Yeah, your answer here is what's over here. If you want to circle it, that'd be perfect. Yeah. What would be an equivalent fraction of 24/36? Aiden.
48/70.
All right. Well, Aiden is not afraid to multiply. If you multiply by 2 over 2, double each of them. We do get 48 over 72, which would be an equivalent fraction. But can we do this another way without multiplying?
Yes.
What is that other way?
I
Add. You may never add to get an equivalent fraction. And here's why. I'll explain why. Okay. Let's go back to this 3/7, just kind of where we started here. If I took 3/7 and I added 2 over 2, I'm taking 3/7 and adding 1.
I just add the number 3 plus 3.
So you're essentially doubling. Okay. Okay.
But it just works better.
Gotcha. Okay, but some people do like to try and add, like legit add to get equivalent fractions. The reason why that doesn't work is because you're taking a value and adding 1 to it. Multiplying by 1 doesn't change the value, but adding 1 does change the value. Right? And if you change the value, they're no longer equivalent. So addition is not allowed. Is subtraction allowed? No, not for finding equivalent fractions. What other operation is allowed? Nora? Division. Because division, like multiplication, if you divide something by 1, the value doesn't change. So, these are both even. Well, I shouldn't say that. What do you want to divide by? Gigi. Divide by 2. They are both even. Let's divide each of them by 2. Essentially dividing by 1, so the value doesn't change. But 24 divided by 2 is 12. 36 divided by 2 is 18. 12/18 is an equivalent value as well. Okay? Like I said, you've done this before, right? But just a reminder that as long as you multiply both numerator and denominator by the same thing, or divide numerator and denominator by the same thing, you're going to get an equivalent value. 8.
For 28 over 20
Yeah.
and 5 over 4, will we have to simplify our answers? Because the top are the
5/4. So here's the deal about mixed numbers and improper fractions. What Aiden's asking is, he got 5/4 by dividing. Wait, how'd you get 5/4?
For
Here's a question.
28 over 20, and then below that, there's a question for 5.
Do you see 3/7?
Oh, down here.
Yeah.
Yeah. So an improper fraction is actually in simplest form, like 5/4. You wouldn't simplify any further. Going to a mixed number is actually called converting, not simplifying. So the further you get in the maths, the less and less you'll use mixed numbers. They just kind of go away. I'm not quite sure why they just do. And so if your answer is as an improper fraction, as long as it's in simplest form like this, that's totally fine. Okay? If you love mixed numbers and want to convert, you certainly can, but it's not technically simplified. Okay? So where are we going with this? Right? Like I said, you've done this before. You can do the rest of these. Where we're headed is that we're going to what's called a proportion. Who remembers what the definition of a proportion is? A proportion. The definition of a proportion is basically two equivalent fractions. So the reason why we wrote all those equivalent fractions up above, you were essentially making proportions. I'll rewrite equivalent so you can see how to. Wait, why is it so you can see how to spell it? Whoa, why is it? There you go. Two equivalent fractions. Okay? You were writing proportions up in the top section because you were writing equivalent fractions. Okay?
So it's basically the same thing.
It's exactly the same thing, right? But equivalent fractions, where they lead us to, are now down below here. You see, I asked you to solve some proportions. Knowing that these two fractions are equivalent, that equal sign tells you that, how can you tell me what n equals? Then,
You can see how much 2 is away from 60, but what do you multiply 2 by to get to 60?
yes, I was worried you were saying, when you said how far away, I was worried you were going to go with addition or subtraction, but no. What we're saying is, what is that scale factor? What did we multiply to get from 2 to 60? Up above, we multiplied by 2 over 2, 3 over 3, 100 over 100, right? Here, knowing that we multiplied 2 by 30 to get 60, means what would we have had to multiply 1 by to get an equivalent fraction? 30, right? What you do to the denominator, you have to do to the numerator. And so that tells us we know that n has to be 30 because 1 times 30 is 30. See that? Right? So for 12/15 equals n over 30, we look at what we know. We know that we somehow got from 15 to 30 by multiplication or division, not by addition or subtraction. What do we multiply by? Let's get someone over here. This half of the room answering lesson. Nolan.
2.
By 2, right? 15 times 2 equals 30. Therefore, up at the top, we have to multiply by the same thing. 12 times 2, n equals 24. Okay. The next one. You are?
On the next.
Next one? So for the next one, we're not going to be using the denominator to start with. We're going to be using the numerator because that's the information that we have here. Somehow we got from 3 to 27. Multiply by 9.
27.
Wait, yeah.
That's 9, right?
I didn't think that went into
Surprise, it does. Okay?
70 divided by 14.
3 times 9 equals 27. So in the denominator, we're going to do the same thing. 10 times 9 equals 90.
I got it.
Okay? It doesn't matter what part of the fraction you don't know. All you're looking for is that connection between the numerator and the numerator to apply to the denominator and the denominator. Or, as in the first two here, what's the connection with the denominator and the denominator to apply to the numerator and the numerator? Yeah.
Is this the thing where you do like for the blueberry thing, you use it 75 times 40 and then divided by 8?
Yeah, so cross product, we are going to get there, not in this objective, but yes, that's how you would solve it. Okay? Next one, 14/17 equals 70 over n. We're given our two numerators, which means that's where we want to focus. How do you get from 14 to 70? Probably not a factor you work with too often, but Enzo?
5.
By 5. So what does that mean we're going to do to our denominator, 17? Multiply by 5. And 17 times 5 is? 85. Okay? What that number is called that we're finding here is called the scale factor. How to get from 15 to 30 or 3 to 27, whatever it is, that's called the scale factor. And with equivalent fractions, they all have a scale factor. Okay? The bottom row here, now our variables in the first fraction, and so we're going to use division. This time, this 24/72, we want to know, how do I get from 72 to 12? This time we're dividing. Yeah, you could use you could, but I'm showing you another way here. Gigi, divide by 6. So in our numerator, 24 divided by 6 equals 4. And it's 4. Now you could have also done, well, I know that 12 times 6 is 72, so what number times 6 is 24? You still get 4. Okay? Multiplication and division are interchangeable operations in this sense. But the way it's set up, you might want to use division instead of multiplication. How do you get from 99 to 33? Divide by 3. So that means we're going to be dividing 51 by 3. What do we get? Ethan?
17.
17. Very good. Okay. All right. Your homework is to finish the first page and do the misdirect pencil section on the second page. Don't do the real world. We'll talk about that in class tomorrow. Don't exit out completely because we will do it. Just don't do it for homework for tomorrow. If you want to, you certainly can, but it's not going to be assigned.
Which one's
Wait, so the 3 word problems are not homework.
Correct. The 3-word problem.
But everything else is homework.
Everything else, you got it. Good. Questions, comments, concerns, complaints, compliments, congratulations, or criticism? We successfully speed ran CO5. Job well done, people. Proud of you. That's how you math. Let's play the number game tomorrow.
Don't forget to like and subscribe.